Good morning once again and welcome back to our class in ESci132, your mechanics of deformable bodies. And now we are on our last topic of our fourth module, which is about torsion. And I hope that you have remembered all these things that I have taught you on the previous four modules. Okay? So the thing that we will be talking about this morning will be about angle of twist. And our goal for this lesson is that first, we should be able to create an equation that will relate your angle of twist and your torsion that is applied to your shaft. Second is to be able to use that equation that we will be developing in solving the angle of twist of a torque-loaded shaft. Okay? So those are the two major objectives for this lesson for today. And now, as you can remember previously on our last two topics ago, we have created an equation, right, that will relate your angle of twist and your shear strain. Unsa ganito natong equation katong taas kaayo natong equation nga gihimo. Can you still remember katong ang atong differential element kay ni twist siya, di ba? Kay kung ato natanawon sa top view naingana na siya, okay, di ba? And then ano yung iyang initial nga kuan, porma, ano yung initial nga porma, and kung ato lang kita on dere o siguro na iyang initial nga porma. Okay? And we know that this one is your gamma. This one is your gamma. Right? And because of that deformation, na ay nahimo nga ing ani nga arc. And diba, can you remember that this element right here, kay ato na nigikuha gikan na sa atong ing ani. So this one is your element, let's say. And this one is the center. And the distance from that one to that one is rho. Diba? So ato na butang yung distance from the center, mga containing center. And ang distance ana is mao nang atong giingon nga rho. Okay? And the change in angle from its initial nga position, which is this one, mo ni atong gitawag nga angle of twist. Okay? And since this one is from this element pa man, so dili ni phi lang, which this is d phi. Okay? So therefore, can you remember kung unsa ning ato na generate nga equation right here? And we knew that this one has a thickness, or this one has a thickness of dx. Diba? Diba? Kay diba ang kaning duha, ang ilang common is ang atong arc length, which is kaning blue. And to get that arc length, diba, nakahibaw ta nga to get that arc length ato i-multiply ang radius or ang kanisiya rho multiplied by the angle in radians, which is d phi. And since equal man na sila og kuan og arc length, then that is also equal to your dx multiplied by the gamma. And therefore, we have generated an equation which is your d phi is equal to gamma dx over rho. Di ba nakahinumdum ta nga ani nga equation sa atong previous nga lesson nga katong libog kaayo na to pag-discuss. Okay? So, let's just focus on this equation na karon because we have this angle of twist right here. And our goal is to create an equation that will relate the torque that is applied to your shaft to this angle of twist. So, mangita tag ato nahibaon nga mga equations before nga mabutang na to ang torque para ma-relate na to ang torque applied ug ang atong angle of twist. And assuming that what we are talking right now is ang kaning material, this one is still behaving linearly elastic. So again, when you say your material is behaving linearly elastic, it means that Hooke's law can be applied. Unsa gani ang Hooke's law? Katong atong modulus of rigidity, ma-apply paghapon to nato nga concept. If ang atong material behaves elastically. So, unsa gani itong atong modulus of rigidity? Diba? Can you remember that it is G is equal to rise over run. Your rise is your shear stress over your shear strain. Okay? And by using this equation, we can substitute your gamma into this shear stress and G. So, that is shear stress divided by your G. And therefore, this one can be further expounded into d phi is equal to, di ba, transpose ninyo, butang ni sa ubos, shear stress over G multiplied by dx over rho. And on your last two topics ago, you learned our torsion formula. And can you recall our torsion formula? Di ba, ang atong torsion formula is equal to T as a function of x rho over J as a function of x. Diba? We learned this one. Okay. So therefore, if we are going to substitute your shear stress right here to here, then we can again further expound this one as d phi is equal to T as a function of x rho dx over G times rho J sa function of x. And in this case, ato lang sa ni assume nga ang kaning atong G is a function of x. Unsa may pasabot ana, ang atong modulus of rigidity will vary linearly from the length of the shaft. Which is, dili man na mahitabo, pero ato lang i-assume for now. Okay? So, gx times rho times j as a function of x. So, unsa na may mahitaboan eh? This one will be cancelled. And therefore, you have your final formula as d phi is equal to t as a function of x dx over g as a function of x times j as a function of x. And if we are going to determine the angle of twist of the whole length of the member of the shaft, then what we are going to do is to integrate that one. So finally, we will have this equation. Okay? So take note of this equation. Because this is the general formula of our angle of twist given the torque that is applied to your shaft. Well, take note, this one is your angle of twist. And this one is expressed in radians. Always take note of that. Your Tx is your torque that is applied as a function of x. So in this case, it is given that your torque along a shaft will vary. So, nag-increase ang torque from here to here. Okay? Ang atong Gx, mao ni ang atong modulus of rigidity sa atong shaft as a function of x again. So, in this assumption nga, ing ani nga function, ang atong modulus of rigidity lahi diri, ang modulus of rigidity lahi diri, ang modulus of rigidity lahi diri, and lahi siya throughout the length. Mao nang G is a function of x. And kaning atong Jx, your polar moment of inertia as a function of x. So, ang atong polar moment of inertia naglahi-lahi daw siya as a function of x. Okay? But this case is not very usual. Kay magvary ang atong torque, magvary ang atong modulus of rigidity, ug magvary ang atong polar moment of inertia along sa length sa atong shaft, which is dili na siya common. Kay ang common kanang constant lang siya og modulus of rigidity, especially sa kanang same ra nga material. Ang magamit tag steel diri unya mahimo na siyang aluminum sa pikas, di ba? So nagvary na ang atong G dira kung ingana ang atong case. But wala ingana. Ang atong steel diri, steel gyapon na siya. So same ra gyapon na siyang modulus of rigidity. So this one is constant. So we can just erase that one, that x as a function of x. Ang atong Jx naabada tay shaft nga solid diri unya inig abot diri mo hollow. Probably siguro natay shaft nga gamay og diameter diri nagtikadakog diameter. Pero dili na siya kanunay nga nga case. Usually ang case nato same ra siya og cross section all throughout. So pwede po na nato i-constant ang J. Okay? And ang atong torque, usually ang atong torque nga gi-apply sa isig katumoy raman. So ang torque diri is constant. So we can also say that your torque is also constant throughout the length. Siguro na po lain nga torque diri, so constant gyapon siya at this point and lahi na po siya at this point. Pero dili magvary ang atong torque all throughout its length. Okay, so we can say that your torque also is constant. So we can simplify this equation further para dili na ta mag-integrate kay kapoy man integration, di ba? Okay, so ingani. So therefore daw, the angle of twist of your whole length of your shaft is equal to TL over JG. Okay? So take note, ingani lang atong equation nga timan-an. Well, kung naatay linear variation sa atong torque or sa atong J or sa atong G, then we should use this one. Pero kung constant lang na ang atong torque, ang atong polar moment of inertia, atong modulus of rigidity, we will use this one. And this one is much common sa atong mga applications, sa atong mga machines and shafts. Okay? So take note. And tanawa ang iyang forma. Tanawa ang iyang pagka-equation. Na siya'y kapariha. Na siya'y murag familiar siyang equation. Kay, di ba, you can recall ang atong equation sa atong deformation due to axial loads is delta is equal to PL over AE. So, di ba, murag related na sila? Your T is your torque sa imong angle of twist. Your P is the force that is applied, your axial force that is applied sa imong axial deformation. Your L is your length of the whole beam or shaft. Your J is your polar moment of inertia kung sa imong shaft. Your A is your cross-sectional area kung sa imong beam. And your G is your modulus of rigidity tungod kay we are talking about shear stress here. So, modulus of rigidity ang atong gamiton. Pero kung normal stress ang atong gistorya, then this is your normal stress. This is axial load. So, ang atong gamiton is your modulus of elasticity. So, dili na ka maglibog og kuan og memorize ani nga formula because they are almost identical with each other. So, with this equation, diri gipang test ang modulus of rigidity sa atong material. Okay? Kaya nga naman, nasila'y tester siguro. Nasila'y ani nga setup. Nasila'y machine. Mga containing machine. Okay? And then, naatay shaft dira ang gibutang. And then, mga containing dira i-read ang kanang atong mga details. And then, kaning shaft na to gibutang diri, gi-applyan na siya og torque dira. Okay? So, therefore, ni-twist ni ang atong shaft. Ni-twist. Okay? So, ang given diri nga makuha na to nga details kay ang angle of twist, ang length of course, ang polar moment of inertia of course, and ang atong torque nga gi-apply. And by having these values, you can now solve for the modulus of rigidity of the material that is tested. Okay? So, for example, morning steel gi-test diri. So, ilagi applyan og torque, known ang length, known ang known ang polar moment of inertia, and ma-measure ang angle of twist, therefore, they can solve for the modulus of rigidity. So, ingana ang ilang pag-test to determine the modulus of rigidity of a material. Okay? Sige. So, how about we have multiple torques? What are we going to do? Diba? In some cases, we have this shaft right here. Nya, na-gear diri, na-gear diri, and then na-gear dira. And then, na-torque diri, na-torque diri, and then na-torque diri. So, nag-vary ang iyang torque. And we are looking for the angle of twist from here with respect to here. So, how are we going to do that? We have multiple torques. So, basically, ang ato buhaton diri, di ba, sa PL over AE ato to isam. So, same goes diri sa atong angle of twist. Imo lang buhaton to get the total angle of twist from this point up to this point. Ang imo lang buhaton is to sum the TL over JG of each segment. So, this is your segment 1, this is your segment 2. So, T1 L1 over J1 G1 plus or minus or plus lang ta karon nya makibaw man ta kung minus kay opposite og direction ng atong kuan T2 L2 over J2 G2. Ganon lang to get the angle of twist from A to B. Okay? So, sayon lang ang atong lesson. And let's have an example. Let's have this first example. So we have a shaft. And then kaning atong shaft, this is subjected to 4 torques. Okay? So your first torque is going right there. 80 kilonewton meter. And after 3 meters, na napoy lain gi-apply nga torque, which is on the other way around. This is 150. And after 2 meters na pod, na napoy gi-apply nga torque, that is going the same sa first, and this is 60. And lastly, nagyapoy gi-apply nga torque padong didto, which is 10. And that is 1.5 meters. So this is your A, this is your B, this is your C and D. And the problem is we have to solve for the angle of twist of end A. Okay? So focus ta sa angle of twist sa end A from its initial nga position. So how can you get your angle of twist of A? Okay, so ang imong buhaton is your angle of twist of A relative to your other end. Okay? So, kung moingon na siya angle of twist of A, automatic na iyang pasabot is relative to the end D. Okay? Sige. So, what are we going to do? First is to determine the internal torques of each segment. So, we have 3 segments right here nga constant ang iyang torque. So, ato na himao nag-diagram. And let's say, ang counterclockwise ang positive. So, musaka kung counterclockwise, unya mo, naog kung clockwise direction. Sige. So, this one is counterclockwise. So, therefore, nisaka siya og 80 kilonewton meter. So, this is 80 kilonewton meter. Walay torque nga gi-apply diri, so this is constant. And na siya clockwise nga direction, so this one is negative. So unsa na may tabuan ni? 80 minus 150, that is negative 70. Okay, and wala na po'y load. And karon counterclockwise na po niyang direction, so nisaka na po na siya. So this is negative 10. And then constant na pod nga torque, and then ana po gi-apply nga counterclockwise direction of torque, which is 10, so nibalik siya og 0. So these are the internal torques of this shaft. Okay? So now, next, what are we going to do? We'll use our equation and ato gamitan og summation. So, therefore, your angle of twist at A is equal to the summation of TL over JG. Okay? So, let's say this is our segment 1, this is our segment 2, and this is our segment 3. So, take note. Importante ang signs karon. Ha? So, kung positive ang 80, dapat positive itong torque. Kung negative itong 70, negative itong torque. Okay? Sige. So, segment 1 is positive 80. 80 kilonewton meter times ang length diha sa atong 80, which is 3 meters. Ang atong polar moment of inertia, we will solve for the polar moment of inertia. Your polar moment of inertia is pi over 2 multiplied by the radius to the 4th power, which is given as 200 millimeters ang diameter. So therefore, kung radius siya, 0.1 meter. Sakto? To the 4th power. So this one is 1.570 8 times 10 to the negative 4 meters. So, therefore, 1.57 times 10 to the negative 4 meters. This is your J. And your modulus of rigidity, which is given man ang type of material, which is A36 steel, and you can browse it on the internet or you can have it on our reference. And your G is found out to be 75 times 10 to the power of 9 Newton per meter. So, if we want to convert that one into kilonewton, so ato buhaton is 75 times 10 to the power of 6 kilonewton per meter squared. Para, again, consistent ang atong units. Kung ganahan kag Newton, then you should make this one as 80,000. Or kung ganahan kag kilonewton, then, di ba, kay 10 to the 9th man ni, so ato ihimog 10 to the 6th. Next segment, this one. So, this one has a negative torque of 70. So, minus 70 kilonewton meter times 2 meters over 1.57 times 10 to the negative 4 times 75 times 10 to the power of 6. Okay? Then last is negative gapon, so minus 10 times 2, 10 times 1.5 over 1.57 times 10 to the negative 4 og 75 times 10. Gitapulan na kang manong. So therefore, your angle of twist at point A is approximately 7.22 times 10 to the negative 3 radians. So, 7.22 times 10 to the negative 3 radians. Ang atong angle of twist sa A. So, pasabot na again. Mao ni ang atong cross-section sa A. Initially, ang atong position before siya sa deformation, ing-ana ang atong line. But after sa pag-apply ani nga mga torques, then ni-rotate siya at an angle of that one. Okay? Ganon lang ang pasabot ana. So let's proceed. Ang ato na po i-solve karon is ang angle of twist from A with respect to C. Okay? So unsa ka naman So your angle of twist from A with respect to C is equal to, di ba? Nakahinumdum mo sa atong graph. This is 80, this is 70, and this is 10. Okay. And ang ato nang gi-focus karon kay kani nga segment up to dere. So, mao lang ni atong i-appeal sa consideration. Okay? So, what are we going to do? This is 80 kilonewtons per meter multiplied by 3 meters over the polar moment of inertia, which is we solved as 0.1571 times 10 to the 3, negative 3. And lastly, so itong modulus of rigidity, 75 times 10 to the 6 kilonewtons per meter squared. And then, since this one is negative, so minus 70, wala ko nagbutang units ha, times 2 over J times G. And you will get your final answer as 8.49 times 10 to the power of negative 3 radians. Dili ko mag-care kung naba mo units inyong solution, basta ang importante, ang final answer ninyo na unit. Pero, for the sake of your solution nga dili mo maglibog sa unit, I would encourage you to include the units kay para makibaw mo kung cancelable na ba ang ilang mga units. Kay base ng isa sa imong unit kay Newton, ang isa sa imong unit kay kilonewton. So, di na nimo ma-monitor kung di ka magbuta og unit. Okay? But I'm an expert, so I can just do anything I want. Okay. And again, this is your final answer. Let's have another example. So, as you can see here, we have a shaft that is attached to a wall. And naitulo ka torques nga gi-apply aning atong shaft. Okay? So therefore, ang imong A mo rotate about point E. But the question is, unsa daw ang displacement diri sa atong tooth P? So ato pangitaon kung pila ang iyang arc length. Ani? S lang ato itawag sa arc length. Arc length sa atong point P, if initially, mao niyang position, pero later, after the deformation, nituyok siya at an angle of phi. Okay? So again, kung saan na ito pag-solve? First thing to do, himutaog diagram. Okay? So again, if counterclockwise ang atong direction sa atong torque, ato i-move pababaw. Pero kung clockwise, ato i-move paubos. Okay, let's do this. So at point A, nisaka siya. Di ba kay counterclockwise man? So this is 150 Newton meter. And constant siya diha. Pero unsa man nasa tong B? This one is a bearing. Ito pasabutan ng bearing. Nag-support lang siya sa pagtuyok. Ang ilang gi-restrict kay ang atong X, Y, and Z direction sa atong force. But it is not restricting the moment, the longitudinal moment of this torque. So, it bears no load. It doesn't restrict the rotation of this shaft. So, therefore, wala siya'y contribution. Next is, diri sa atong point C. Atong point C, na siya'y clockwise direction nga torque of 280 Newton meter. So therefore, ninaog ni siya, 150 minus 280, that is 130. Right? So, this is negative 130. Okay? And constant na po na siya dira. Uy, kami naog na po og 40. So, 130 plus 40, that is negative 170. Constant. So therefore, pila ang gisupport sa imong E? Of course, 170 Newton meters ang imong gisupport sa imong E. Okay, so pasabot na ing ana siya and then 170 Newton meter. Okay? Ana lang. So, we have to determine the angle of twist of A with respect to E. Sige. So, unsa gani ato buhaton? Well, nakahinumdum ta again that your angle of twist is equal to TL over JG. So, therefore, this one is 150. Di na ako magbutang unit, kikapoy na. Basta Newton meter siya. L of 0.4. J of, solve pa ta si J. So, ang J is equal to pi over 2 times pilay radius and assist. So, diameter is 14 millimeters. So, that is 0.007 meters, I think. Radius, di ba? Okay. To the fourth. Kagamayan eh. So, therefore, this one is... So, this is 3.771 times 10 to the power of negative 9 meters. Kuya 1. So, again, this one is 3.771 times 10 to the negative 9. And then your G is given as 80 gigapascal. So, that is 80 times 10 to the power of 9 Newton per meter squared. Sakto? Sakto. Next, negative. So, minus. 130 times 0.3 over J, which is this one, and G, which is this one. Kapoy na suwat. The next is 170. So, negative naman. Negative 170 times 0.5 over J and G. So, therefore, your phi at A is equal to, your angle of twist at A is equal to negative 0.2121 radian. What does this mean? Nganong negative man siya? Di ba positive to ang atong counterclockwise direction? So therefore, since this one is negative, this one, instead of rotating like this, counterclockwise, it rotated the other way around. So, ang nahitabo day niya is monang initial and then morning final, rotate siya pa yung ana. This is your phi, and that is your 0.2121 radians. Okay? Now, in order for you to get the arc length, your S, di ba kayo mawa niya itong gipangitang displacement sa imong tooth P after sa iyang deformation, ang imo lang button is S, or your displacement, is equal to radius, which is given right here as 100 millimeters multiplied by the radians, which is negative 0.2121. And you have a final answer of 21.2 millimeters. So, negative, whatever, pero 21.2 millimeters ang arc length niya. Okay? And this one is your final answer. Diba sa yun lang? Easy breezy. Ang taas lang siguro kay ang kaning solution. Pagbutaan ni sa inyong calculator, probably this will take time because this has a long equation. Okay? And the others are just as easy as a cake. Okay, let's have this last example. And this last example is kind of tricky. Kay naa siya duha ka shafts nga magtapad. So we have these two solid steel shafts and nagtapad sila and they are connected by a gear, and we are going to look for the angle of twist at end A if there is a 45 Newton meter torque that is applied on that end. And take note nga inigtuyok nimo sa end A, mutuyok ang B, and inigtuyok sa B, mutuyok ang C. So there is a a deformation from D to C, and there is a deformation from B to A. So we are looking for that one. How are we going to look for that one? So our first goal is to determine the internal torques in each of the segment. So I think you already know the torque in segment AB, right? Because it is given there, muna mong segment AB, and sa isig katumoy lang siya gi-applyan og torque. And this is your gear. So therefore, the internal torque in this shaft is only 45 Newton meter. Okay? So 45 Newton meter ang imong gi-apply nga torque dira. Okay. But how about on your segment CD? How will you know the internal torque of segment CD? If the two are connected on these two gears. So, ano na siya? If we knew that this one has an internal torque of 45 Newton meter, and we knew the radii of both gears. This one has a radius of 150 millimeters, and the other one has a radius of 75 millimeters. And unsa may common ani nilang duha? Nag-touch sila dire. And then ang common dira is ang force nga gi-apply. Diba? And we knew that your torque is equal to force times distance, or basically that is the radius. Okay? So we can relate both of these two gears by their force. So therefore, T1 over D1 is equal to T2 over D2. Kanon lang. So this relationship we can use to get your torque at segment DC. Okay? So, anong gagawin natin? Your torque 1, which is 45 Newton meter, your diameter, or let's say your radius na lang, ay, yeah, di na to, kaya ang radius madiin yun, di diameter. So this is 150 millimeters. We can just use 150 millimeters because it will cancel out to the other D. Next is, what takibaw, T2 over your second diameter, which is your second radius, 75 millimeters. So therefore, your T2 is probably 22.5 Newton meter. Am I right? Yes, I am. Okay? So therefore, the internal torque in your segment DC is 22.5 Newton meter. And this one should be rotating the opposite direction. 22.5 Newton meter. Okay? So, let's continue. So, ato sa tanan ng angle of twist sa C. Diba kay mo ni atong D and then mo ni atong C. So, ato sa tanan ng angle of twist sa C with respect sa D. Kay di ba nagtuyok man ni, so dapat ato ni appeal og account sa pagtuyok sa atong A. Okay? So angle of twist sa atong C. Angle of twist sa atong C is equal to 22.5 Newton meter multiplied by the length of 1.5 meter over J. What takibaw sa J? So we will solve for J. So both shafts has a diameter of 20 millimeters daw. So we will have your J can be solved as pi over 2 times, so 10 millimeters ang radius, 0.01 meter squared. And that is approximately 1.57 times 10 to the negative 4 meters. Okay? And again, that is 1.57 times 10 to the negative 4 meters. And your G is 80 gigapascal, so Newton meter man ta, so 80 times 10 to the power of 9. And we will arrive on an answer of 0.0269 radians. Okay? So, unsay nahitabo diri sa atong snowman? Ato ibalik lang drawing. Okay. So, diri sa atong snowman, initially, maoni. Nagkatungod na sila. Ba? But, after nag-apply kag 45 Newton meter diri sa atong end A, ang nahitabo, ni rotate ang atong end B ug ang atong end D. Diba? Ni rotate na sila. So, ang kaning rotation, this is your phi C, lagi. And we solve that is 0.269 radians. But, take note, nga ang kaning nga angle ug kaning nga angle is different. And this is what we call your phi B. Kanang different man sila. Kay of course lahi sila grade. Kani lahig radius, kani lahig radius. So, unsa may kapareha nila? Well, ang ilang kapareha is ang arc length. And we knew that your arc length is equal to phi times the radius. Diba? So, in order for you to get phi B, since S1 is equal to S2, diba kayo mamaning S1, and this is your S2. So, if S1 is equal to S2, then basically, your phi C multiplied by the radius of C is equal to your phi B multiplied by the radius of B. Okay, so we will have this equation. Okay, and unsa man to imong phi C? Ang imong phi C is 0.0269 multiplied by the radius of C, which is 75 millimeters, is equal to phi B, which is, we don't know, and your RB, which is 150 millimeters. So therefore, you will get your phi B as 0.01345 radians. Okay? Diba? Easy breezy. Oh my gosh. Okay. So this one is 0.01345. Okay. Let's proceed. Diri na ta. Unsa ganito ito gipangita? Unsa ito gipangita na eh? Unsa ito gipangita? Ato gipangita is to solve for the angle of twist at end A. So, di ba kay ni-deform ni siya, kay na siya angle of twist. Tungod sa iyang pag-deform, then nituyok niya ang atong phi C. Therefore, nituyok po ni atong phi B. But wala lang na limit dira. Kay nga naman, naapoy deformation diri nga segment because of the 45 Newton meter nga load. So therefore, nituyok po niya naapo ni angle of twist ang atong A with respect to B. So, we will also solve for that one, and then later on, when we solve for the angle of twist of A with respect to B, then we will add this one to get the total deformation or the total angle of twist of your A. Sige, let's do this. Sige. So, your angle of twist of A is equal to internal torque, 45 Newton meter, multiplied by the length, which is 2 meters, over J, which is, we solved earlier as 1.57 times 10 to the negative 4, multiplied by the modulus of rigidity, which is 80 times 10 to the 9. Okay? And we will solve that the deformation of your A with respect to B is equal to 0.0716 radians. Pero we're not done yet because this one is your A with respect to B pa. Wala pa ta nakasolve for the total angle of twist of A, which is equal to 0.0716 plus 0. Asa to ako na-solve ganiya? 0.1345. So therefore, your final answer of your angle of twist at A is just equal to 0.0850 radians. Nahagets mo sa ato pag-solve? Nahagets mo nga na ako giad? Again, ako giad kay ang kaning 1345 maoning rotation tungod sa atong segment DC. And sa pag-rotate ana, ni-rotate po niya ang atong gear B. And pag-rotate ana atong gear B, napod na siya angle of twist ang atong A with respect to B, so ato giad ang duha. And we have this final answer. Okay? Understood? I hope nga nakasabot mo sa atong lesson for today because this is our last lesson for this year. And at least na lang sa last lesson sa inyong na-learn sa 2020, nakasabot yun mong maayo. And this is a fun topic. Though, libog siya at first, pero once you will be able to know this one better, then mag-enjoy mo og-solve ani nga mga problems. And take note also, na uban nga parts ani nga by analysis lang akong pagtanaw. Sa akong pag-add, ako na nag-analyze. And kamo, pwede po mag-analyze sa pagtuyok-tuyok sa aning mga gear, unsa iya pag-rotation. So, importante po na sa inyong pag-solve. As a summary for this lesson, we have created an equation that will relate your angle of twist and the torque that is applied. And we have also learned how to solve that equation that we have made. And shara. So, I hope that you have enjoyed the topic for today. And again, this will be our last topic for this year 2020. And I hope that you will enjoy your Christmas break with your family. And kita nga mga single, wala tayong mga jowa, then I hope nga mag-enjoy gihapon ta bisag bugnaw ang atong Pasko. Ay, charot na to ha! Charot na to. Okay, so Merry Christmas to all of us and I hope nga naamoy madawat nga mga gift, no? Bisag gift of love na lang from your family. Bitaw, bahala mo diha. Bahala mo magsigara mo ML. Adyo pa mag-review na lang mo. Okay? So, I'll miss you. Bye-bye. Thank you for your time. Thank you for mura po tagdi ta magkita. Balik. Bye na.